And going to the next one, okay, the similar one till now we had seen the sensor side, the actuator side. I was trying to mention like right, like in the from the beginning brakes and all. So here also not only brakes, there are plenty of other actuators like intake air throttle. So air throttle position sensor I tried to explain right, like some kind of amount of own gas only they are trying to take inside. So that's where this throttle uses. So throttle just moves from 0 to 100% position. So if it rotates some 20% position, so remaining 80% will be free and 80% gas will come inside. So if it is a half block 50%, then 50% amount of gas will come into the picture. So it's like a basically it's an actuator. And intake air compressor actually rotates round and fast, and it will just compress the air. So that's the reason the intake air compressor is there. Charge air cooler and intake valve, pressure control valve, these are all, everything is like a valves are like a simple solenoid valves. You guys know solenoid valves, right? It has like a move front or back. Only linear motion is allowed. So kind of a similar way. Some kind of easier valves are rotational basis, and exhaust valve and camshaft and crankshaft. These are also there, and turbo and injectors. So you have seen some kind of a piston is going up and down in the engine graph, right? That's what the injectors are talking about. So everything is an actuator. So everything is an actuator, and you are able to control over the ECU. So every sensor input will be fed to the ECU. Every actuator will be connected to the ECU. Everything is controlled with respect to the ECU. And going to the further IC engines, what are the different things are there? So we are talking about the regulations of BS4 and BS6, right? So why exactly this BS4 and BS6 into the come into the picture? So previously, let us say some 40 years back, there are no regulations. Why there are no regulations? Nobody bothers about environment pollution there. So now exactly why they are bothering about it? Because it exactly impacting the ozone layer. And many of the greenhouse gases, which are many plenty harmful gases are there, which are exactly impacting our human health also. So they came up with these regulations. Every other country in the earth, so not only the India, it's in US, it's in Germany, it's in Europe, everywhere, in Australia, everywhere it is there. So how exactly these guys are controlling this exhaust gas into the non-harmful gases? So obviously after burning, there are very much harmful gases. You, as I mentioned at the starting, there is a particular filter to filter the smallest particles, which are called as soot particles. Not only soot, there is nitrogen monoxide. It's a quite harmful gas, which is the one of the dangerous gas, NO, which is getting released after the burning of the fuel. And NO2 is a quite a little okay compared to NO. So these are called as a NOx exhaust gases. And SOx also is there. Sulfates also there. SO2, SO3, everything is there. So all SOx is also there. And you will be having other gases like a carbon dioxide as an outcome. Okay, so and water, surprisingly water is also an outcome of our engine exhaust. So if it is a happily burnt, it's 100% working as expected, you should be able to see water outside of the vehicle from the exhaust pipe. So but it's not like 100% combustion is successful, or as much as we want, and the chemical reactions are not as much as we want. That's the reason we are not completely getting water as an out product. We are getting mix of just water and other stuff. So here we will be seeing what are the different gases, how exactly they are going to exactly control over the harmful gases into the normal gases to the environment. So here you are able to see a cooling system, which is the diesel engine, you can able to see, right? And the very next to diesel engine, you will be able to see a diesel particular filter, DPF. So what this guy is doing, I already mentioned this particulate filter. It will just extract the smallest particles, black smallest particles from the exhaust gas. So it will just accumulate all the exhaust gas particles in this particular portion, so in this cylinder, and it will just release only gas outside of this. And what will happen after that, the exhaust gas will come into the picture, and there is a unit called diesel exhaust fuel tank. Okay, what is this guy is doing here? What is DEF? So we know gasoline as a fuel and diesel as a fuel. What exactly DEF? Diesel exhaust fluid, what it is? So are we filling any DEF fuel? Yes, people are filling DEF fuel in premium vehicles and trucks and buses. You will not be able to see in the moderate range of cars, but you will be able to see in the high, very high-end range of cars, and very mostly you will be able to see in the trucks, buses. These are all the main uses for this DEF. And this DEF exhaust fluid, what exactly this thing? This is a secondary resource of fuel? No, this is not a secondary resource. It's not like a hybrid engine. It is only used for mixing some kind of a urea inside the exhaust gas. So urea, you know, NH3, everybody knows urea. So this is like a urea, like a light amount of this urea fuel fluid will be there. People call it as like a AdBlue. Okay, AdBlue they will be calling, and AdBlue will be filled in these tanks. What will happen when the exhaust gas comes? Some amount of AdBlue will be injected towards the exhaust side. You will be able to see DEF doser, right? So there is the place the some kind of a AdBlue will be injected into this portion, and what will happen? This will get mixed with the exhaust air, and your exhaust will be having a dangerous nitrogen oxygen components, which will get mixed with this. That is a NO you call, just simply for guessing, just call it as a nitrogen monoxide is getting released of exhaust, and NO is the name, nitrogen monoxide, and NH3 is for urea. Both NO and NH3, so two N's are there, right? So coming out of, after the chemical reaction, it will just come out of N2 plus the other subcomponent will come. So compare it to NO, N2 is a very better gas. You know, people now filling with the tires, right? uh, Previously people fill with the normal gas, but now nitrogen. So it's not a harmful gas. Basically it is a not very harmful gas. Nitrogen monoxide, yes, very much yes, and nitrogen dioxide is not that much, it's also yes. So basically n plus n, this combination is getting added, and getting N2 as a byproduct, and you will be, so here you are getting eliminating your harmful nitrogen monoxide. So after this mixing, it will go to SCR catalyst. So selective controlled. Okay, what exactly selective control means? Nothing but these gases only. That complete operation, whatever it happens, will be happening in the SCR only. And output of this SCR catalyst, what is nothing but nitrogen plus water to the environment. As I mentioned, water also a very much component to be expected out of the exhaust pipe, but nobody knows that from exhaust pipe water comes, but it's actually practical and it should come. It is not coming, and nitrogen is not a harmful gas anymore, because nitrogen monoxide, yes. So this is how the system exactly working, the sensors and actuators in the IC engine. I tried to explain the most portion of it, and below is the left side, you can able to find some kind of a information which I gave through the session. You, what are the different components: dock, DPF, SCR, urea tank, temperature and pressure sensors. So these are all components which are involved in this exhaust gas treatment, from the harmful gases to non-harmful gases. Okay, going to the next slide. And the introduction about the vehicular networks. Yeah, I gave a very brief introduction about at the beginning itself. So to communicate, okay, you are sending a signal. There is an ECU. Let us say you are trying to rotate your steering from 10% you rotated, but it has to convert from 10% to 90%, right? So how, who is getting converted? ECU. I mentioned ECU will convert. So how exactly this communication of, you are just turning 10% of steering which will be recorded using the position sensor. Let us say position sensor is there. Okay, you recorded 10% of change here, and 90% should come outside. So how exactly this 10% of change is being sent to ECU? So how exactly this communication is happening from the steering column to the ECU? Is the CAN, link, FlexRay, most, these are all like a vehicular network. So how exactly, so you guys know, as you are, you see I2C, I2C communication, you very well know, right? This, there's like a protocol how exactly it needs to communicate, right? So quite a similar way, CAN, link, and other stuff are a very similar way. It's a communication protocol, how exactly one node to another node it has to communicate. You will be able to know in I2C master and slaves, right? Very similar fashion, master and slaves here also will be there. And so that is how this CAN, link, and FluxRay others and came into the picture. And I can mention CAN is the most used in the automotive. So people require the skill of CAN, and without CAN there is no vehicle. If you see any vehicle, CAN is there everywhere, in bus, in car, in truck, everywhere it is there. CAN is the highest used technology protocol in the vehicles, um, in the for communicating between the one node to another node, like a master to slave. So this is a small intro about the vehicular networks. And I just mentioned a small examples like a ABS CCU to ADAS CCU. I will brief about ADAS much later in the slides, and how vehicle speed is getting displayed over the dashboard, where the origin is a vehicle speed sensor, right? So vehicle speed sensor is placed at the almost near to the tire side. Now how exactly your vehicle speed is getting displayed at the dashboard, right? So how it is like which line is communicating, who is showing you the value, how exactly you are getting displayed is nothing but with the communication protocols. So can FD and other stuff, everything. And how does remotely unlocking car works? Yeah, IR, right? Like with the unlocking key, you're directly unlocking your vehicle door, right? So this is also one kind of protocol. There are plenty of examples like this, like others, when you turn on the light, it just turns on. How exactly it is turning on? It's not a simple electric circuit. You are just giving the information to ECU, and ECU should turn the light, tell the light to, okay, just turn on. That's how it actually works. So this is the quite a introduction about the vehicular networks. So I just tried to mention here can FD, LIN, FluxRay, most, and other stuff are the communication protocols here. And okay, as I mentioned, CAN is the quite interesting protocol because every other uh, vehicle is using this technology. Okay, let's know about this CAN, a little introduction about it. So initially introduced by 1986. So CAN was coined by Bosch. So most of the people knows about the Bosch company. It is like it is not only in the automotive sector; it's everywhere. It's the home appliances and other way around. It's in electrical. Everywhere it's in medical. Everywhere it is there. Not only in the automotive side. So in automotive side also it is present, and they declared or they invented the scan protocol. Nobody else, and they invented, and every other manufacturers, every other suppliers are using the same CAN protocol to use as a intra-vehicular communication. Okay, and the speed is like a 1 MB per second is the maximum, faster, safer, and reliable. Yes, we can talk about the CAN in the further slides. So what exactly this CAN is doing, ECU to ECU, it just communicates by transmitting messages from one ECU to the other ECUs, and the other one is like there is no way to transmit message only to a specific ECU. Okay, let me explain how this protocol exactly working. Okay, and so how exactly this guy is working? Okay, one ECU to another. So here you can see in the middle picture, right? Can low, can high, and ECU1, ECU2, ECU3. So what exactly these guys are doing? So ECU1 is nothing but, let us assume there is an engine ECU. ECU2 is a brake ECU, let us say. Okay, and what exactly will happen? Let us say your some message from brake. So brake message will be sent over the CAN channels. So it will be delivered to the every other ECU which is converted connected to the network. That means if you send an e message, then ECU 1 also receives, ECU 2 also receives, ECU 3 also receives. But ECU 2 only accept the message and process it. Why exactly the ECU2 only is accepting? Brake is more relevant for the brake ECU, right? So it is relevant for the brake ECU. So which are all, it's a quite relevant or for that particular message, then only that ECU will receive. Other ECUs also will receive it, but it will never accept it and it will never process it. So that is how it is like a one transmission, but multiple broadcasting. So every other node in the network will be receiving the messages of every other message it will receive. But what it wants, it will just accept it. So that is how this CAN communication is working now. So, and coming to the standard frame of the CAN, you can able to see the standard frame of the CAN here in the bit. So basically it's a combination of a different type of datas. So first thing is like a startup frame, we call it as a recessive bit there, one, and ID, standard identifier. So what exactly, how exactly ECU2 is accepting while ECU3 is not accepting, while ECU1 is doubted whether it has to accept it or not. So how exactly these guys are getting decided? So every message will be having an identifier of a 11-bit identifier. So based on this identifier, this ECUs recognizes, okay, this message is fits for me, and this message I need to take it and process. And it will also decide like it is not fit for me and it should not process. So this identifier is like a name to us, okay, and name just if it fits or not fits, simply. So to identify it. And RTR control is a quite a simple bit. So there is a difference between a standard frame and a extended frame, where exactly this bit is getting used. And data frame, okay, this is the interesting guy. Okay, you are sending a message, okay, you are sending some 10% of fact pedal I pressed it, or 10% of brake I have applied. So where this 10% is getting conveyed, okay, you are naming your message with identifier, but how exactly this message data is getting communicated? So here this is the frame, this is the data where exactly the data fits in, like 10%, 20%, 30%, how whatever the data you want to send will be there in this place. And the CRC, okay, this guy is a little interesting guy. Cyclic redundancy check, people calls it as, okay, you are interested, you are sending some information via electrical wires. How you know that you have sent 10% and you receiving 11% as an information? How you can assure that, okay, whatever the data you sent is 10% only? How the receiver knows that, okay, this guy sent to me only 10%, it's not 11%? This guy can tell about that. So what exactly the CRC is doing? What this guy, a simple algorithm I will explain. Like let us say it will just add all the bytes, all the bits in the data field and other frames, identifier and other frames, data field. Let's assume data field. Okay, just add it, sum over it. Let us say I got 7 when I am transmitting with 10% of brake pedal. 7 is my count. Okay, once after receiving it by ECU2, and it just calculate, it will just sum up the data. However, how it is exactly calculated the transmitting side. So transmitting side, you have just added and gave the count of 7, right? 7 will be sent over here, and it will also, what it will do, it will also sum up the data and see at the receiver side whether my 7, the sum is equals to the CRC or not. So if both are equal, okay, this guy whatever he sent, I just realized it correctly. If it is not correct, I could have got different count, not the 7, maybe I got 8. So that is how they're just re-verifying that, okay, that's the reason, re-verifying that, okay, the message transmit is proper and I have received is correct. And acknowledgement, okay, this guy is also is something like, there are two types of things are there: positive acknowledgement and negative acknowledgement. So the transmitter transmits the message to you, and you received it and you processed it and you do whatever the job you want to do. Done. But how the transmitter knows that okay, you transmitted correctly to the ECU and it received it? So there should be an acknowledgement, right? Either it is a positive acknowledgement, that means I have received it properly, yes. If it is a not received, then okay, I have not received, there's a negative acknowledgement. So the receiver should send an acknowledgement, is a positive acknowledgement or a negative acknowledgement. And end of frame, it's like a stuff bits will be added into the message frame. um, so like a very small introduction I tried to give. To know about CAN, it takes minimum 3 to 4 hours of session to talk about the each and individual sessions and how exactly this master slave communication or multicasting is working in the vehicles. So that is how it's a kind of a big lecture. Um, this is the smallest intro for it. And standard frame and extended frame, I tried to explain here. So standard is nothing but the 11-bit identifier. That means only 11 bits are used for identifying your the message. 29 bits is like much bigger than 11, right? So you can actually name plenty of others. You have 11 factorial combination here, you have 29 factorial combination here, right? So it's like a more number of messages if you require, then go for it. 29-bit identifier. So people uses 29-bit identifier in trucks. Basically, it requires plenty of ECUs, so people call it as a 29-bit identifiers. So people are going for extended frame in trucks, standard frame in cars. Okay, little introduction about the CAN only. Here you can able to see the first picture under arbitration text. So you're able to see the bus signal, right? So bus is nothing but the electrical wires, which is there CAN high, CAN low in the previous slide. You're able to see the orange line and blue line, right? So they are nothing but these CAN lines, and there only your electrical signal will be transformed. So since you are electronics, you know about TTL, right? TTL logics. So more than 2.5 volts, I just consider as a positive and 1 bit. If it is less than 2.5 volt, okay, consider it's less than 0 volts. So 0 bit. So it's just a voltage division. If it is a more than 2.5, just declare it as a 1 volt, one like a boolean one. And if it is a less than 2.5 volt received, then boolean 0. So that is how exactly is passing through the electrical signals, it will just communicate. So here you can able to see, right? So bus, so initially it just went down and went up. So constantly down for some time, constantly up for some time, and constantly down and up for recessive bit. So here, so there are 1, 2, 3 below are there, right? So let us say there are different messages. There are three messages which are transmitted in the bus. So all the three messages received at the receiver node. But which message it has to take first? All are transmitted at the same time, more or less. It is not possible, but let us say all the messages are transmitted at the same time. But which message I need to accept first? So how it has ECU has to know, okay, I have to accept first one message only, not 2 3 messages. Okay, first one message, thereafter third message or second message. How it actually knows? So this is the arbitration in CAN, where you will get to know which message you need to first process it. So here you can able to see. So here also at one, let us say consider. Before going to this, you have to know about 2 bits: 0 as a dominant, 1 as a recessive. I try to mention in the left side. Dominant means it is a 0 and the recessive means it's a 1. So who have the dominant at the last will be having the highest priority. So that is what the CAN says. Okay. Okay, we will see who is holding their dominant bit at last. Okay, let us see after first message 1, 2, 3 are there, right? And what first message, if you see, all the three are going down, all the message identifiers are going down. Okay, no one win, no one lose. Okay. And second one, you see, second message have a recessive edge, not the dominant edge. And third message also having a recessive edge, but not the dominant edge. So 2, 3 having the dominant edges, but first message have the recessive edge. First message will be having the recessive edge, right? So the similar way, so who is exactly losing here is nothing but your one is getting loose here. And while going to the next one, okay, let us see. 2, 3 are now quite a similar one. Okay, left one leave it because it lost. So it is a last priority to me. And 2, 3 are having the same message structure, right? Same plots. Okay, fine. Next, go to the next sector. So okay, both are having a recessors. Okay, fine. The very next sector, if you see, third one is holding a recessor, right? Upper one going up is nothing but a recessor. So third one is having the recessor, but second one is having the dominant edge. It went down, right? So that's the reason second message won the arbitration, and second message will be received, I mean processed first by the ACU, thereafter third, thereafter first. So 2, 3, 1 is the order. So this is how the arbitration is being implemented in the CAN. So if multiple messages are received, they have to see according to this algorithm, and according to them only it will just process the messages. Okay, we talked about the messages, how multiple messages are received and how it is getting processed. And going to the different types of frames are nothing but messages. So nothing but like there are different four types of frames. A data frame is nothing but consists only data, and remote frames are nothing but, so you are just sending the data to transmitter, right? To receiver side, whatever you requested, it has to go through the remote frame. And an error frame. Error frame is nothing but, okay, your NAC acknowledgement. I told, right, you have to send an acknowledgement whether it is a positive or negative. So if it in CAN also we have an algorithm called as like a passive error and active error. So while when it reaches a 255 error count, the bus has to stop the communication. So it will never allow you to send any messages in the bus if it reaches a 255 error count. So that is like error frames talks about. Overload frame, if it is overloading the frames, like overloading the messages. Let us say there is an extra delay between the sending and the data and remote frames. That's where this overload frame also comes into the picture. There are four types of CAN frames overall. So this is how the introduction about CAN. Okay, going to the next topic, diagnostics and vehicle and standards. Okay, at the right side, you will be able to see some kind of a serial numbers with respect to UDS services. What is UDS? Unified Diagnostic Services. I mentioned at the starting, at the beginning, that okay, you have a number of components in your car, and you who knows that which component exactly failed. You never know. Okay, these services will be helpful, and this diagnostics will be helpful that okay, this problem, okay, your air filter is causing the issues, okay, your brakes are failing because it's actually not working properly, like it's rotten or it's a short circuit battery, or anything is happening, anything with respect to electrical side, or anything with respect to wires are not proper, anything. So everything you will be getting to know about this UDS service. So if what is the services? Why exactly are called as services? So you cannot just read the services. You cannot just read the diagnostics by just connecting some kind of equipment. So you need to send some commands and receive the messages and process the messages to know the information. So to send the commands, there is some restrictions. There are different commands, right? Okay, I need to read the information only, or I need to reset the particular equipment to 0% or to higher percentage. So let us say 100% I need to set. So different components you can able to control using this UDS services. So these are all main important services I tried to list it down here. So every service will be having a service identifier. You can able to see diagnostic session control 10, ECU reset 11, security access 27, tester present 3, and etc, etc, etc. So these are all the different services available. So as I mentioned, using services only, you can able to fire some commands to your ECU, and you can able to receive the messages back to your component and process the messages. can see exactly what I'm talking about. Okay, this is the brief introduction about it. And ISO, here I'm trying to mention about some kind of a standards like ISO 11898 2, ISO 11898 1, ISO 15765, 14229, J1939. So these are all like a basically standards. So who is providing the standards? Yeah, so there are different organizations are there which are controlling this automotive vehicles, like a Society for Automotive Engineers called as SAE, and plenty others like in Pune we have actually one, and plenty of others are there, and this ISO also one kind of a standards which it will be providing. So every vehicle must follow these standards to implement this CAN architecture. Okay, and physical layer talks about the electrical voltage things. Data link layer about the communication. Network layer again about the communication, but not about the data. And UDS system talks about the diagnostics alone, not about the communication. So principal diagnostics, but people call it as a one is onboard diagnostics, and another is outboard diagnostics. So basically, Jeevanandran, you will be able to see in the trucks, not in the cars and behind cars. There are two addressing mechanisms too, physical addressing and functional addressing. Uh, so to talk about this addressing mechanism, let us say you have a one particular message which is relevant to only one particular issue, not to the multiple issues. Let us say I have five different nodes are connected, five different issues connected in my same network. Okay, one is trying to transmit to 2 3 4 5. Okay, but one wants to transmit only to 5, but not to 2 3 4, right? So in that case, physical addressing it can use. Okay, it can actually utilize only fifth address, but not the 2 3 4 address. Only fifth address alone it can use, and it can transmit the message. So one-to-one communication I was talking about. So it's a physical addressing I can talk about. Okay, let us say assume a call. You might be calling some person. It's a one-to-one communication only, not the conference call. Okay, if it is comes under the conference call, it's a functional addressing, or a radio is the best example for the functional addressing. One will be sending the messages, and everybody else will be receiving the messages. Will be it should be a functional addressing basically. So these are the two addressing mechanisms are there in the CAN. Okay, I was talking about positive and negative acknowledgement, right? I will give a small intro about it. Okay,
Hey
here.
Varun, am I audible?
Yes, yes, yes.
Yes, Varun. So sorry for interruption. Actually, we are like going beyond the time. Can we just speed up a little bit and have some time for Q&A session and close this session as soon as
Sure, sure,
possible?
sure. Yes,
Yeah.
yes, yes.
Okay.
Sure.
Thank you, Varun.
Yeah, thank you. So these are positive response and negative response, and response suppressed. Okay, I was talking about. So this remote laptop is there, right? This is the your equipment, and you're sending commands to your car, and car is responding back. It's responding by a positive or negative, anything, or it cannot send any response in case it's faulty. So these are all different types of diagnostics over the CAN. And okay, I was talking about the errors, right? Different types of errors. This right side table, blue color, which talks about the different types of errors which can occur when you are firing the command. So plenty of errors are there. There is a different classification which was there in UDS. And yeah, how exactly you are going to fire the services commands, or you are connecting your laptop towards the car? How this using this OBD2 connector? So to every other car connector, you can able to see here this under the car steering. You can able to see this column, nothing but this OBD connector. And to this connector, you will be able to connect with the bottom device, the yellow one or orange one. And so you will be able to request the diagnostics, and you can read any information with this device. And the other one, which is right side to that one, which is looking like a mobile phone. And the next one is like a wireless Wi-Fi. It's like a Zigbee protocol. It just connects, and you can receive the data in the through Wi-Fi to your laptop or anywhere. Or you can just record the things in this thing, and you can actually play it after some time. So these are all like diagnostics through CAN in the car. This is the connector, which it looks like it's a 16-bit connector. And error memory management, I was talking about different errors, right? How exactly the errors are classified. So here you can able to see the right side diagram. P0302, right? So P says powertrain. Powertrain includes your engine and your transmission side, everything is the powertrain. So if it is a P, it is a engine trouble or transmission trouble or an exhaust system trouble. So if it is a chassis component. If it is a C at the starting, it's a chassis trouble. If it is a B at starting, it's a body trouble. That is, a door is not fitting well. It's a body trouble error code. Okay, and the second yellow one talks about the standardization. Like it's a manufacturing specific code or it's a standard code. It talks about 0 or 1. If it is a 1 for manufacturer, and 3 is something about the which subsystem you're talking about. Okay, what kind of a subsystem is faulty here now? So that talks about this. So it's all predetermined according to the code. You can be able to go through the manual and see it, how, which subsystem exactly getting affected by the code. Okay, so this is the code which will be responded from that OBD2 connector, and you can actually know, okay, this component got failed. So this is how the error memory management comes. EOL diagnostics, I spoke a lot about it. I was telling this OBD2 connector, right? It's connected to your laptop or any by any means you can connect, and you can just fire the services and read the services. You can know the faults. You can calibrate the engine to the best economy and everything. Like you can see the calibrations. You can configure the part numbers. You can calibrate the diagnostics to a different way. Everything you can do. So this is how the connection looks like. Evil diagnostics, I already gave a very good example at the beginning about the evil diagnostics. And okay, which are all the tools used to communicate over car and your laptop is nothing but this canopy. So plenty of other tools like Cano, Analyzer, Monaco. So there are like some other tools in the industry which are there. Okay, these are all different tools. These are all like a softwares. If we mainly from the industry, people are looking with this Cano skill and Canalizer skill and Canopy very lightly. So basically, Cano is the major skill people are looking in the automotive sector. 90% people will 99% will be knowing about CAN in automotive field who are working. Okay, evolution in the automotive field. I talked about the engines. Okay, started with the external combustion engines in the trains. After the internal combustions, like a bike, car, and all. And coming to the very next slide, the very next generation is like a hybrid generation, mix of two fuels. And the very next generation is like electric, which is yet to come. So this is how the engines are getting transformed, and we are now in the century where electric is the future. By 2030, everything will be going to be electric in the developed areas, not in the India, but developed areas. Everything will be going to be electric. So the existing vehicles they will not be selling, but the one they will be selling will be the electric only. And yeah, they should follow the Euro regulations for the conventional engines. I just tried to mention here. I also mentioned the career path and job opportunities. Yes, there are three different types. Initially, I talked about two only, right? Like a product supplier and OEM. So service based are like a some companies are there like a L&T and Tata, TCS. Also, plenty of other supply service based companies are there. What they will be doing, they will be hiring people and they will be sending to either suppliers or either to the OEMs. OEMs are nothing but the Volvo, Mercedes, everywhere. So this is how the chain in the automotive market. So product-based companies and OEMs are much better companies compared to service-based. But from service-based, they will be on-siting to the OEMs, and you will be working under OEM or a supplier. So at least I try to mention some companies which are located in Bangalore here, like Mercedes and Hyundai, Mahindra, Tata Motors, JWM, Ola Electric. There are these companies are OEMs comes under in Bangalore, and there are plenty of Tier 1 companies, but I try to mention some 4 or 5 of them: Active, Autoliv, Bosch, Continental, Tata Alexei, Harman, etc. So all these companies are like a Tier 1 suppliers, and everything comes into the hiring philosophies, electronics and electricals only. Mechanical is a quite a less, quite a less, maybe some 10% odd, but 90% mostly electronics and electricals will be there. And the primary skills which they are looking are like a CAN, Ethernet, UDS diagnostics, hill testing, DSpace, ETAS, vehicle know. So basically CAN and CAN are the quite important if you want to get into this domain. The other stuff are related to the work environment. And Python coding is very much good if you have it. And Jenkins also is a highly appreciable skill which companies are looking at.